Okay, we're going to talk about how to get every single SAT percent question correct. Okay, so there is going to be a percent question on the SAT. There can be more than one. You're going to get every single one right if you do it this way. Okay? Alright, first of all, let's talk about the different types of percent problems.
Alright.
Okay, so you can have percent of. You can have percent change. You can have what is the percent.
What about interest? Does that fall into this?
Kind of, a little bit actually.
Is that a different thing?
It's very, very much related.
Okay.
Okay, so this one is kind of like the weird one. This one, it's not really weird, but it's one that you know how to do already, and we're not really going to talk much about it. This one. Alright, that one over there, that just means like, let's say you have, you're taking a test and there's 120 questions on a test. Unfortunately, Super Bowl party was the day before the test. Didn't really study. Thought you knew the French vocab, but you didn't. So turns out you got a
I get a weird number.
You got a 72 correct. 72 correct. Okay. So what was your percent correct? What is the percent?
So we're gonna set it up 17. 72
is percent.
X equals 120, and then we'll do that division.
Nope.
What?
Yep. Nope. So what is your percent correct? So let's say this is a real life test.
Yep.
You got a Scantron. You got 120 questions. Of course, the Scantron marks the ones that are wrong, but let's just pretend the Scantron marks the ones that are right. And it goes, and you got 72 correct out of 120.
Oh, correct.
Correct. How do you do that? It's going to be 72
divided by 120.
Divided by 120.
Yeah.
It's what you want, like the percent of what you want out of your total.
Yeah,
okay?
I don't know.
72 out of 120. Like, I don't want to give you out of 100 because if you got an 82 out of 100,
it's too easy.
You got an 82. You got a 0.82. And what is a 0.82?
82%.
You got 82%. Okay, so we're going to do 72 out of 120. We're punching the calculator. And we're stalling because we're getting the calculator. And we're going to find it to be 72 out of 120, 0.6.
All right.
What does that mean?
60%.
You got a 60%.
Or 60, or 6 out of 10.
That would be right. So you got a 0.6, and you can put as many zeros as you want. So we'll just go ahead and put a 0. Bling. And then you multiply it by 100. But multiplying it by 100 just means
you move the decimal.
Times 100 equals, yeah, it just means you move the decimal. You go bloop, bloop, and you end up with 60%. You with me? Okay, so that's a more basic kind of question. A more difficult one is a percent of problem. Okay?
Yeah.
Percent of. I hope that comes up in the audio.
Yeah, I do too.
Okay, so percent of. We're really going to think about percent of. Percent of. Because when we do percent of, think of it as like it shrinks the number down.
That's one of the topics, and I couldn't figure it out. So I'm really happy we're going over this.
What do you mean?
It's the percent that shrinks it down. And I was like, how do you do this?
Okay, so shrinks the number down. So let's make it apply right here. Let's say you sell houses, right? I know someone who sells houses. She's very successful, and she could potentially sell like a $1.2 million house. Okay, so $1.2 million house. How do you rate that?
1.2
That's 1.2 million. That's not actually how you write it, because if you were to get a check, like a paycheck, and it's at 1.2 million,
Oh, okay.
you go like this. It's 1,200,000.
Yeah.
Okay?
Mhm.
And if you're in the real estate business, perhaps you get 3% of that. Technically, I think the seller has to pay out 6%. But the realtor, the agent, unless you are your own company as well, you're going to get a 3% commission.
Mhm.
Okay? All right. You with me?
Yeah.
3% commission. So let's throw out some numbers. Is it possible that you're going to make $10 million for selling that house?
No.
Why?
Because we're not even selling it for that much.
Yeah. Is it possible you're going to make $5 for selling the house?
No, that's too little.
It's too little. Okay. So what you're going to do is you're going to say, all right, well, I'm just going to write this as a question. What is 3% of 1,200,000?
You're gonna multiply them.
You are going to multiply that. How'd you know that?
Because what equals x is equals 3% is 0.03 of equals multiply.
Okay, that's really smart and huge. Of means multiply. Cool. So you're going to go and you're going to get your 0.03. What? Let me rewind and delete that.
Hmm.
What's 3% in decimal language?
0.003.
0. Point what?
0.03.
Like that?
No.
Like what?
Take out one of them zeros.
How'd you do that?
Because I know that.
How do you know that?
Because it's common.
Well, how do you uncommon sense it
Oh.
and teach it to a sixth
All right. Well,
grader?
if you're gonna move the 100, if you're gonna move the decimal point, you still gotta move it twice.
Well, do you go twice to the right or twice to the left?
You go twice to the left.
Why do you go twice to the left?
Because that's how I was taught.
Well, you go twice to the left. Over here, you go twice to the right because you're multiplying, because you're going from decimal to percent. All right? And percent is really just for looks. You don't do any math with the percent symbol.
Mhm.
But to go the other way, you divide it by 100.
Mhm.
So you scoot to the left 2 places. It's actually really important to know that.
Mhm.
You have to know that you're dividing it by 100. Because you'll get problems on the test that say p%. And you can't do math with p%. So it's like it's 0.0 p. Yeah.
It's really irritating.
Yeah. So you're dividing it by 100. Okay. Let's go over here. Go like that. Divide it by 100. You with me?
I'm with you.
All right. So, and you said perfectly that you're going to multiply like this. You can have the honors. What's your fat commission going to be? Can you buy a car with your commission?
Probably not.
Probably so.
How many zeros am I needing? 5?
Uh-huh.
I can definitely buy a car.
Mm-hmm.
3,600.
So 36,000. So you're gonna make 30, and what? Boom! Sell a house. You get a check for $36,000.
That's where it's at.
Right there. Boom. One transaction. Okay. So that's 3%. So let's kind of think about what just happened. So you have. Here's a number line. Here is 1.2 million, which is $1,200,000. Here's $0. Okay? And here is somewhere over here. I don't know why I do it like that. Is 36,000. And what is 100% of 1,200,000?
100% of that is that.
All right. So what's 100% of 1,200,000?
1,200,000.
Okay. So this is 100%. And what is 0% of 1,200,000?
$0.
$0. And what is 3% of 1,200,000?
3,600. Thousand. You know.
So you're correct. First of all, it's kind of bugging me that there's not a little line right there. Okay, so let me show you what's going on here. When you're at 100%, if you say, all right, I want 100% of, when you do that of, you're going to go like that.
Right.
Okay? When you do 50% of, you're going to go
Stop in
the middle. So when you start hitting that of, are you shrinking or is it growing?
It's growing. No, it's shrinking.
It's shrinking. If I do 25% of, you're going to go
shrinking.
Right? If I do 1% of, it's going to go. Now you make the sound effect. Right? If I do 3% of, it's going to go right there.
Yeah. Oh, yeah. Right.
It's not really to scale, but that's my 3% of. So when you hit by of, boom, it shrinks. Makes it smaller.
Means multiply. Multiply means smaller.
Multiply means
you're
smaller.
using a fraction or decimal.
Yes, yes, yes. Okay, you with me on that?
I'm with you.
Okay. So that's how you do those types of problems. Now, you can have a question like this. It says, what, or you could say like let's see here. Oh, by the way, what we're addressing right now is we're addressing these types of problems right here. Okay? So if I say like 30 is what percent
30
of, if I say 30 is what percent of 73?
All right, I got
Right.
this.
Wait.
Oh.
We're going to go ahead and we're going to put our number line down here. We're going to go ahead, we're going to go like that. And we're going to go, why not? We're going to go like that. And we're going to go like that.
All right.
And we're going to put our 73, what number goes where?
73.
73 goes here. Why'd you put 73 there?
Just because that's, well, if you want to make it to scale, then it'd be 73 on this side. But
no, like
we don't need to do that.
It has nothing to do with this problem. So like, why is the 73 here?
Because it's the biggest.
It's the biggest. Okay, now what?
Then the 30 in the middle one.
Okay. Here's the 30.
And then 0, because that's where it's nothing.
0. Okay. And is this a shrink down situation?
It is, well, 30 is what, it's not really a shrink down, aren't we just trying to?
Yeah, well, some sort of percentage made us shrink down to 30.
Then it is a shrinkage.
All right, so there's a formula. We didn't talk about it, but we used it. And the formula is amount
This, I'm unfamiliar with this.
is equal to P times R. Let me think about that. Yeah. All right. So amount is what you get after the percentage has been applied. Okay, so like future amount. Let's say future amount. And P is principal. Principal just means starting off original amount.
So 73 in this case.
Yes. Principal, which is just the original amount. And R is your rate. It's your percentage. Your rate. And what I'm teaching you to do, and this is tough for every single SAT student, I'm going to retrain the way you do percentages. Okay? Because if you do it the way that you do it, and everyone pretty much does it the same way, you'll get about 33% of them right. If you do it this new way, you're going to hit them all.
Alright.
You're going to knock them all down like whack-a-mole. Okay, like a good whack-a-mole player, not like a bad whack-a-mole player. Okay, so we go over here. So we're trying to find, well, do we know our future amount?
Yeah.
What's our future amount?
30.
Boom. Do we know our principal? Or I guess it's principal.
73, yep. It's
We
the
do
original
know.
amount.
Yes, the OG amount. And do we know our rate?
We don't.
So we're trying to figure that out. So we're going to use a little algebra. So what do we divide both sides by?
73.
Divide both sides by 73. Divide both sides by 73. And we're going to do what?
We're going to divide that.
Now I give this lesson. I probably have given this lesson a million times. And some students take to it and forget. And it's okay you forget because it's going to be kind of complicated and weird. But some students revert to how they used to do it. You don't want to do that. You want to do it this way.
This is actually making a lot of sense because I was doing these, and I was like, "Why isn't this coming out correct?"
Okay, so they're all going to be set up the same way.
And I wasn't, so I could do that with any of them, any percentage.
Well, yeah. When we're done with this lesson, you will. There's more. Okay, so you have 0.41. So what does that mean?
41%, and that's the rate.
41%. 41.
Wait, that's the rate of change.
No.
Man.
That's that 41%. That's your shrink down.
Mm-hmm.
So look, 100% of 73 is 73, but 43% of 73, or 41, whatever that number was, 41% of 73, you go is 30.
Got it.
Okay, so when you apply your rate, you're going to get a shrink down.
Got it.
Okay. Now, I'm going to throw this little lesson in here just because it's kind of cool. It's a little side note. Shout outs to Mimi from 10 years ago who taught me this. Alright, so Mimi must be like 30, no, 28 by now. Alright, but I was working with Mimi and we were doing percent problems. And I didn't teach her anything. I just wanted to see what she could do. And she started to do this percentage problem. And she said, we'll call it Mimi's way. Let's call Mimi's way. Okay. And I heard her whisper something. And I said, whoa. She whispered to herself. I said, what did you say? And this is what she said. But this is only going to work. I didn't used to teach it at all because I don't want people to get confused, but it is very useful.
All right.
It only works for this. Okay. The problem that we've done, this problem right here, it'll work for that one. The shrink down problem.
But I still could use that one too.
The other way is just very powerful. This is just a
fun.
This is just a way that'll everybody just gets. It's not complicated. It's very simple and very good. Okay, so Mimi's way does not work with percent change problems. Will not work with percent increase. Will not work with percent decrease. This way, when I teach it to you, will work with everyone. But Mimi's way is kind of cool, so here we go. So she whispers to herself as she's trying to do this problem. In fact, I'm going to write the problem down.
All right.
30 is what percent of 73? So she's reading the problem.
30. See, my worry with this is that I'm going to forget which ones go with each.
Like by telling you this way, you'll get confused, you mean?
No.
30.
Just with all of them.
Oh, it's okay. You'll get practice. 30 is what percent of... So she's reading this problem. And then she whispers to herself under her breath. I had to have her repeat it because I was like, you know a trick?
This is life-changing.
And she said, percent over 100 equals is...
Oh, she did some cross-multiplying?
She said, percent over 100 equals is over... Actually, she said, let me see. Percent over 100 equals is over of. And so, I was like, So, let's set it up. I'm a little worried that my rectangle isn't big enough. Percent over 100 is equal to is over of. Okay, so, well, we're looking for what percent?
So X.
X over 100 is equal to is. 30 is. 30s are is. 30s are
Definitely,
is.
can you... Yeah.
30s are is. There's our is. There's our 30 is. All right, so let's get our 30 in there. And there's, oops. We don't have consistency. We don't have anything. Okay, and what's our of number?
73.
Our of number is 73. Of 73. Of 73. Oh, no, it's not blue. Okay, 73. And then you cross multiply. Okay, so you go 73x
equals 3,000.
Equals 3, and then 1 0, 2 zeros, 3 zeros. Yep, 3,000. I'm not going to panic about this rectangle.
Yeah. Good. Very good.
All right, so then we got divide by 73. Divide by 73. Now, the way this problem is set up, though, it's actually set up to give you the answer in percent language, not decimal language. So it's 3,000 divided by 73, and we have 41%. You can plug in for that, not for that, but you can plug in for that, or for that. You just plug in the unknown, and you got your answer using Mimi's way. Okay. Only works for the top one, though. Okay, now watch. Now, I've modified it a little bit, and I'm like, well, you don't really need percent over 100 if you understand that it's you can just do percent equals is over of, and if you just recognize that if they give you like that this answer that you're going to get right here, or the answer that you put there is already in decimal form.
Yeah, so it just puts you into like.
So that like this answer would be 0.25.
Right.
Right. So then
it's just 25% instead of having 25.000.
Right. So. Yeah, so this x, let me see.
Which is handy, but if you know how to already do the decimal points, it's not necessary.
Right, so x over 100, so I'm just going to leave that out. I'm just going to do x instead. X is equal to 30 over 73. All right, so that's my revised Mimi's formula. Percent equals is over of, and you get 30 over 73, 0.41. And then you say, what's that percent? That puts you in decimal form.
Mm-hmm.
So what's
41?
It's 41%. Okay. So I thought that was so cool when she showed me that.
She's an intellectual.
Okay, but you don't have to know that. So let's go back to this. So do you understand that this formula right here?
Yeah.
You can plug in for the unknown also. You can plug in here. You can plug in here, and you can plug in there. Okay, so A equals P times R. Let's try. So if I say, so we have A, I think I did I do that one? Or no, I didn't do it yet. Did I not do it yet? Let me see. Did I not work out that problem at all? Am I going crazy? Wait, it's right. Yeah, it's right here. I did it already. Right?
Yeah.
So that's it. Right? So 30, that's the future amount. Okay, equals 73, because that's your...
Oh, 73 over R.
Yeah, so is 73, which is what you have now, but it got chopped down, and then you divide both sides by R for 73. Right? So you're going to get...
But then would I multiply 30 and 73?
No, so step 1 is 30 equals 73R.
Oh, okay.
Right,
okay.
so future amount is new amount times interest rate.
Right.
Okay, or percentage rate, whatever. And then you divide after that. So then step 2 is right here. You with me?
I'm with you.
Does that all make sense?
Yes.
You sure?
Yes.
But
I can only do this with percent of change.
This is not a percentage change problem. This is a shrink down problem.
What is the mathematical term for that?
A shrink down problem. It's a percent of problem.
Percent of, not percent of change.
No. Step number 2.
And that A equals PR is only for percent of. Only.
Yes, but what I'm about to do is I'm about to connect percent change to this idea. So it's all connected. It's all related. So here's step 1. Here's step 2. Let's review what we know so far. But this time, we're going to do this with something, let's say, a $400 Apple Watch. So let's, you have an Apple Watch.
I did for a week.
Did you really?
Yeah, I returned it.
Oh, that's interesting because I wore a watch. I put a battery in a watch that I got like 15 years ago, and I was like, let me see if I can wear a watch and get used to the idea of wearing a watch to tell time.
Couldn't do it?
Couldn't do it. I took my phone out every single time to look at the time. I would drive in the car, my hand would be on the steering wheel, my watch would be facing me, and I'd look at the time like on the car, or I'd be with somebody, a student, and then I would just take my phone out and look at the time. I could not break it. Okay. So I was like, I'm not going to use it. So I just saved myself $400. Okay, so if there's a $400 Apple Watch, and let's say tax is.
Let's make it a weird number.
Let's make it
10%.
Beautiful number, 10%.
10%.
Yeah, tax is 10%. These are just not real sentences.
Tax is $40.
Yep. Okay, so how much do you pay in taxes? Okay, so conceptually, you got your line in blue, little lag there, and you have your 0, and you got your 400, and where's that 40? But we know that number. Where's it gonna end up? Where's it gonna be?
On this side, more to the left.
Like there?
No.
Like really far over?
Yep.
Closer to the 0, maybe?
Way closer to 0.
All right. So we got our 40 here. This is going to be our 0%. This is our 10%. This is our 100%. How's it going?
It's good because my team just won.
Did the Patriots win?
Philadelphia won.
Cool.
Yeah. On the last play, they threw it to the goal line and it was knocked away. But it was a great thing. It was a great game. 41-33.
We're having a video recording right now.
It's okay. It's gonna be famous.
Wait, did the Patriots win?
You're watching the football game?
No.
No, the Patriots lost.
No.
Yes.
Okay, go on.
I'm very happy about that. I gotta feed these dogs, so excuse me.
No problem. Ready?
Yeah.
All right.
You ready, Rocky?
So what's happening is that 10%. You had your 100, but then with that 10%, you got your right. The formula to do that is this one here. New amount equals P times R. And that R is you're going to make... What's the P stand for again?
Percent.
Does not stand
Principal.
for that. What does that mean?
It's just what it is.
Principal is the starting number.
Oh, right.
It's the money you put in.
Can we not call it the principal? Unless it be called it.
It's actually called the principal.
Oh, so we can't call it S.
No. Because you're going to see... That's how it is in books. Okay, so that's principal. And so this is starting number.
Yeah.
There was 93 points in that game.
Okay.
Yeah.
Over 1,000 yards.
But you could say that it's also the original number.
And yet the biggest play of the game was made by the defense.
Oh my god.
Original number. You could say it's the OG number.
Alright, that's what we'll call it.
What does OG stand for?
Original.
Right. So you think if your principal at your school is original gangster, you are good to go.
Yeah.
Alright, and what's A?
Amount.
Amount. Original gangster amount or amount in the future?
Future.
Future amount. So this 40 right here, is that 40 the original gangster amount or is it the future amount?
It is the future amount.
Alright. So let's make up a problem. You make it up. We have to... Let's see.
Right.
This could be the answer. This could be the answer. Or this could be the answer. Hopefully I didn't write the question already. Oh, I did. I read the question already. So
should we make a new one?
No. How much did you pay in taxes? No, let's make it this one. So now just set it up. How much did you pay in taxes? So what's the unknown?
The unknown is... Well, we don't really have an unknown. What is tax? What is tax?
We know it, right?
Yeah, we know it.
Let's go ahead and look. I'm going to erase your memory. Oh, gone. Wait.
It's
Oh, no,
there.
just kidding. That was wrong. It's gone. Okay.
Oh.
So what do we plug in?
Okay, so we're gonna do A, which is still A. No, it's not.
Well,
Yes, it is.
yeah, because we're gonna figure out our.
So A, because that's the future amount. We don't know our future.
We don't know it. Wink, wink. Okay. All right. So
Mom, can you shut the door? So we have A is still A because we don't know.
A is still A. All right. P.
P is the OG.
It's OG.
That's our good one. So 400
400. And R.
is the rate, which is 10%.
Should we? All right. Are we good to go? Should we just punch these two numbers out in the calculator like that? You're about to get it wrong. Do we use a percent symbol in math ever?
Wait, 40 times 0.1.
Yeah, you never. This here percent. Like, look. There's like no calculator out there that has a percent button on it. No, there isn't.
That's a shame.
It's a shame. There are actually, but they're
But we don't need it.
but they're for people that just
They're lazy.
yeah. I haven't seen one in a long time. You're not gonna get one in scientific calculator. It's like an oxymoron. Okay. I wouldn't want that scientist. That's my scientist. All right. So you got this right here.
There we go.
All right. What is that? Is that going to make 400 grow or shrink?
Shrink.
Yeah. What would make that 400 be exactly 400? What percentage would I put here to make that 400 be exactly 400?
Okay, you're gonna have to move the decimal over.
Yeah, but what percent would it be so that it's exactly
0%.
0%? Like, let's just say you go and you're like, how much Apple Store are my taxes? The Apple Store is like, well, we opened up this new state called State X, and in State X, the sales tax is actually, like, according to our calculations, an additional $400. Taxes is not $40; it's $400. So what's State X's tax percentage rate?
100%.
100%. It takes you. It's a full amount.
Right.
Okay. So, but in this case, we're not in State X. So
Something they do too. Call it that.
you're gonna go and you're gonna find that it's 40. We shrunk it down.
Yeah.
You with me on
I'm
this?
super with you.
All right. So here's our progress bar in becoming percent ninjas.
Uh-huh.
Okay. So here
Right
is,
Uh-huh.
and here's ninja. We're there.
Almost.
Almost there.
Okay.
Okay, so here's the one that throws everybody off. Percent change. Okay, percent change. There's some code words for percent change. Means the same thing as percent change. Gotta watch out for that. First one,
Oh boy.
percent increase.
Okay. And then
Yes.
percent decrease.
Yes. The most difficult thing about this whole process is trying to mirror image this original squiggly thing. I'm not very good at. Oh, there we go.
Okay.
Percent decrease. Okay? They're both like percent change. So they could ask you in the test, what's the percent increase? They could say, what is the percent decrease? They can say, what is the percent increase? Or they can say, what is the percent change?
Yeah.
Kind of means the same thing. All right, well, let's say we go and, before we really dive into this problem,
Okay.
we're going to ask ourselves if an Apple Watch is $400
And is now
and tax, that's not really a comma, and tax is, if an Apple Watch is $400 and tax is 10%, now we have a comma. How much do you pay at the register? Which, by the way, is a trick question because they don't have registers at the Apple Store. Okay, so how much do you pay at the register? All right, so I think you know this answer.
I think I do know.
What's the answer?
440.
You pay $440. and you do this problem the way everybody does this problem, which is the way I encourage you to do for the rest of your life, but it's going to fail you on the SAT. Okay? So, we're going to talk about that. So, what you did was you went...
We have to do it with like a weirder number.
No. And I'll tell you why. So 0%, just not now.
Mm-hmm.
And then you have 400%, or sorry, 400. So, sorry, not percent. $0, $40. This may be deja vu. $40.
X.
$40. And we know that we also figured out that this is 10%. Right? So 10%, we went from which is 100% to right, by hitting it by 0.1. You did 400 times 0.1, you got your 40.
Got it.
Okay. So then, because I'm somewhat of a mind reader, okay, I am a mind reader, I know what you did.
What did I do?
You said, all right, Steve, A, I know how to take 10% of numbers, but B, even if I didn't, I would just go 400 times 0.10. Then you get 40. Then I go 400 plus 40, and I get my 440. And that's absolutely correct. But you're going to get it wrong on the SAT. So, because once I start throwing letters at you, left and right, and there's no numbers, and you have nowhere to go, and you're being chased by pit bulls, you need something else. Okay, so you're going to want to see, so your answer ended up being over here, right? Your answer ended up being 440.
Right.
So we're going to do it the way the cash register does it, because the cash register does not do it the way that you just did it. The cash register does it in one step. You did it in 2 steps. You said 400 times 0.10, take my answer, add it to the 400, and that's what I pay. The cash register is going to say, whoa, 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 whoa. If it could speak. It would say, whoa, 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 whoa. Why would I want to do 2 steps when I can just do that? That is not 10%. 440 is not 10% of 400. 440 is... Do you know? Do you know what it is? Because
it's over 100%.
It sure is. In fact, I can tell you what the over 100% is.
All right.
What is the over? How much over 100% is it?
110.
Yeah, it's 100. This is 0%. This is 10%. This is 100%. This is 110%. So this right here is a 10% increase. But do you see that? You know how we talked about how of problems shrink things down?
Yeah.
How we talked about you go from there, and then all of a sudden you go to like there.
Yeah.
Right? Well, when you take a percentage of something over 100%, okay, your 100% takes you there, and then the amount over the 100%, instead of going backwards down to here, or like instead of actually going like whoop, you're gonna, because you're at 100, you're gonna go start here and then go whoop, and you're gonna go right to the answer. Okay.
So would it be 400 times? Well, I'll let you keep.
Okay, so I'm gonna adjust our formula. What's our formula?
Is there really a formula?
Yes, it involves OGs and principles.
Are we still using that one? So A equals PR?
So A equals P. Now watch. Here's the new formula. 1 plus R. Okay, now this plus right here, this is your percent increase. This is 100% in decimal language. This is 100% in decimal language. Okay, so why is that? Why is 1 100% in decimal language?
Because it's complete.
No,
It's a whole number.
no. Well, let's see. I want to do 20%, 30%, 50%, 60%, 90%, 13%, that's just really random, 91%, 99%, 99.999%, and 100%. Okay, what is 20% in decimal language?
0.2.
0.2, I'll put 0.20. What's 30% in decimal language?
0.3.
0.30. What's 50% in decimal language?
0.50.
What's 60% in decimal language?
0.60.
What's 90% in decimal language?
0.90.
And then what's this guy doing here? What's 13% in decimal language?
0.13.
What's 91% in decimal language?
0.91.
And what is 99% in decimal language?
0.9. Wait, what is it? What's the one?
What's 99% in decimal language?
0.99.
0.99. If I just wrote this like in money terms, by the way, like you went to buy something and it cost this much, how much money is that?
It's 20 cents.
20 cents, all right? How much money is this right here?
It's 91 cents.
91 cents, all right? How much money is this right here?
That is 99 cents.
99 cents, okay. And what would this be, by the way?
0.99999.
0.99999.
Which will round to a dollar.
And for the moment we've all been waiting for, what is 100% in decimal language?
1 point.
1.
Oh. If you
Point
want
oh, which is the same thing as 1.
Mm-hmm.
So this is 100% in decimal language. Got it? There's your 100%. But that, the beauty of this 1 right here, is it makes your starting point here. Okay? And then when you tack on to that, your 10%, well, that just means if I put my 1 here and I tack on my 10% in decimal language, well, that's my percent increase. But together, what does that make?
110.
110. And what is 110 in percent language? Or what is 1.10 in percent language?
110%.
110%, which says I'm not going to do bloop. Instead, I'm going to do bloop, which is just the same thing as just adding bloop onto bloop.
Yeah.
Make sense?
Yep.
All right. So then I go over here, and I say, all right, my principal, my OG amount. How much is my OG amount?
Your OG amount is 400.
400. And this is the program they have at the register. And you get your calculator, and you go 400. You do it, right? 400 times 1.10.
What is it?
400 times 1.10.
It's still the same answer.
Ta-da! So, I don't know if you realize what just happened, but let's just say I erase your memory, and I say, Jenny, if taxes are 10%, and if the Apple Watch costs $400, how much you pay at the register? Well, do it old way. Do it your way from an hour ago. What would you do?
Well, I would find 10% of 400.
Step number 1.
Yeah.
And then what would you do?
Add that to 400.
Step number 2. Here, it's done in one step.
But how would that still be wrong in the SAT if I did it my old way?
Because I'm glad you asked. I'm going to use easy numbers. I'm going to use the same numbers, but it could be done way harder. So, John paid the Apple Store.
Let's use a different number.
No. John paid the Apple Store $440 for the Apple Watch. Taxes are 10%. What is the original, or what is the before tax price of the watch?
Can I just do 440 divided by 10? Or times 0.1.
What is the? I'm gonna address that in a second. What is the before tax price? And this is where you fall on your face. Okay, so ready? But don't worry, I fell on my face in this exact problem at the age of 25. Okay, so here we go. So 440. If you go 440 times 0.10, you're taking 10%
Wait, I'm
of
gonna get
440.
44.
You're gonna get 44. So then you say, all right, no problem. I'm gonna go 440 minus my 44 and be like, aha, I'm going to Stanford because the original price is 440 minus 44. Take that, College Board. 396. Oh yeah, which will be option C on the test, by the way. And wrong. Okay, because I think you kind of figured out why. You know why?
I know why. I don't know how to explain why.
Because you're taking 10% off the higher number.
Yeah.
The number that has the percent built into it, right? You need to find the number that the percent was applied to.
Yeah.
Right? So we take our handy dandy percent increase formula and we say, all right, amount equals our OG principal times 1 plus R.
Right.
Right? All right, well, what do we have here in this problem? We have this number here.
Mm-hmm.
Is that the OG number or the A number?
No, it's not the OG number.
Is it the A number?
A is for the total amount, yes.
Okay, so 440. And what are we trying to solve for in this problem?
We're trying to solve for the R.
We are.
We are not.
I see R right here. There you are, R.
Oh, we are not. We're trying to solve for P.
Solve for P. So I'm going to go P, but see, I know this is a percent increase problem because taxes made, that 10% made my number grow. It's not a percent increase. It's a percent increase. It was increased by 10%. Okay? So I'm going to go 1 plus what's my increase?
Your increase is 10.
My increase is 10, which is secretly 110 right there. So then P times 1.10 close equals 440. All right? And then
we're going to divide, right?
We're going to divide. Divide by 1.10. Wow. Divide by 1.10. 440. Divided by 1.10. 400. Now who's going to Stanford? You. Okay? Now, the reason why, and the kids don't believe me. I don't know why they don't. They go back to their old ways. Let's go back to our problem here. And go over here. Here. Let's give you an SAT problem. Oh, that's cute that number is there.
I hope that laugh made it.
P dollars. R percent.
See, why are you doing that?
In terms of P.
Okay. Okay, so let's write out the original formula.
All right.
Which
Right.
equals A equals P plus, no, parentheses, 1 plus R.
All right. So John paid at the Apple Store P dollars. Where does P dollars go?
P needs.
I don't. You know what? I don't want to. Just because we're still in learning mode.
Yeah.
Let's make this Q dollars. Make this Q dollars, and we're going to make this in terms of Q, and we're going to make this M percent.
Oh, that's tricky.
Okay, here we go. So, in terms of Q, I guess, and M, I suppose. Okay. You ready?
It's really hard. Yeah.
Here we go. So do you see how you're like, oh, I'll hit the percentage and then add it to this and that, and it doesn't work anymore.
Yeah.
You need something you can just count on and plug it in. All right. So we have this right here. So Do we have our A?
We do not.
We do not have our A.
So A is still A.
John paid at the Apple Store Q dollars. Well,
Q is kind of A because that's the total amount.
yeah, we do have A. Q. All right. Now what?
Okay. So P is the OG.
P is the OG.
We don't have that.
We don't have P, so what should we call it? That's right, P.
Oh, okay, we stay with P.
Times.
1 plus M, because M is the rate.
And your answer is going to be option C on the test.
Mm-hmm.
You think you're going to Stanford, and then boom.
Yeah.
Not going to Stanford.
Yeah.
You know why? Because you put a number in decimal language. I mean, percent language right in there. So if this was 25%, you just dropped in at 25, not a 0.25. Okay, so what do we do?
All right. We're going to do point M?
That tells me you don't really understand what's going on.
No. M over 100.
That would work, but how would that help? That would work. So remember, if you're going to go from percent language, how do you go from 25 to 0.25? How do you go from?
We're moving the weight. We are dividing.
So it's
Or
you
multiplying.
are dividing. So it's two places to the left.
Yes.
You went when you said point M. It's not point M.
It's M point. Oh.
So it's normally here. This is just M.
Yeah.
That's the same as that. Okay, but you got to go. When you go from percent, you're making a smaller number. When you go from percent language to decimal language, so you got to go bloop, bloop.
But, okay, is that just assuming that M is like a single digit number?
It's assuming M is anything. M can be 35%.
But then, wouldn't it be 0.035?
We don't know M.
Okay.
So because we don't know M.
So the 0 is just always there. There's no like weird mathematical thing.
No, it's just you have to just go two places over.
Oh, to make it the.
Because let's say M was. Let's say let me think. If it is, it's because you know what it is, because it's M over 100.
Yeah.
Right, and M over 100 is 0.0 M. M over 100 is 0.0 M.
Yeah.
M times 100 is M, like whatever that number is with two zeros at the end.
Yeah.
It's a moo. All right, so yeah. If you wanted to, it actually makes a little bit more sense to do what you initially said. I kind of like what you said. You said,
I'm over 100.
yeah, I like that. So you did this. Because then you actually get to keep that same nice looking M right there. Right there. Okay. You with me?
Yeah.
All right. Okay, so now you go Q, which is what we're looking for, right? What is it before tax price?
We don't have it.
Oh, sorry. What is the? Oh, in terms of Q, no, we're not looking for Q. We're looking for P.
In terms of Q and.
So
wait.
we want P equals something QM.
Oh, we do on P on its own. Yeah.
All right. So you're gonna go like this, and then you're gonna distribute.
Ew.
So you're gonna go. Well, boom. What do you have?
P.
P. Then what else do you have?
PM over P10.
No, because it's like P is P over 1.
All right.
And then times M over 10. And in multiplication of fractions, top talks to top and bottom talks to bottom.
Oh, yeah.
There's just an invisible 1 right there.
So PM over P.
One more time. Top talks to top and bottom talks to bottom.
Yes. Which equals PM over 100.
Wait. Bottom. Bottom.
That's a 10, right? Oh,
Yes.
PM over 10.
Yes, equals PM over 10. So you got a PM over 10.
Yep.
Cool. Now what I'm going to do is I'm going to flip this sucker. So I'm going to go like this. I'm going to go P plus PM over 10 equals Q. Did you see what I did?
Yep.
All right. So now,
Well.
Okay.
We can cross out those P's.
You cannot cross out those P's.
Mm-hmm.
They're adding. So
Not those P's. Oh, it's a 10. I keep thinking that's a P.
Oh, right here?
Yeah.
Okay. So let me rewrite this a little bit. So this is the same thing as P plus P times M times 1/10.
I don't like it like that. I'm not feeling it.
Well, another way to think of it as, well, we have to thought bubble this thing. If you have a like x plus xy,
Mm-hmm.
you can factor out an x. What do you end up with?
X plus Y.
No, so
XY.
no, x times what?
X1 plus Y.
Okay, cool. Now, if you had this,
Well, we can still pull out an X.
you can still pull. You can. Well, you can. First of all, you can. Actually, you know what? Okay. We're gonna go ahead and just jump right into the problem.
All right.
All right. So the way you can add these two together on the left is you have to have a common denominator.
All right. So we have to make it 10,
Correct. So you have to go like this, and then you go 10 here
which means 10P.
and there. Perfect. So you're gonna go 10P over 10 plus PM over 10 equals Q.
Yeah.
Now you can add the tops.
Yeah.
What do you got?
We're gonna get 11.
See, 10P can't talk to PM.
So 10P. Oh, still a plus. Plus PM?
All over. And the reason is because let's think about what 1/2. So 1/2 plus 1/2 over 2, since you have the same common denominators, you can do all over one of the 2's.
Yeah.
And then on top you have a 1 plus 1. What's a 1 plus 1?
2.
So you have 2 over 2, which is 1, and we know that 1/2 plus 1/2 is 1.
Mm-hmm.
See, so when you have both the same, you can put the tops together all over one of the bottoms. Yeah. All right. So now you can go ahead and you can factor out what from the top?
P.
Good. Pull a P out from the top, and what do you get?
We get 10 plus M.
10 plus M over
10.
Cool. And it says, the question actually said in terms of Q, right?
Q and M.
Right, and
Right?
wait, in terms of Q and M, you're right. Okay, so then we have to get, wait, it said, what is the before tax price? Yeah, so we have to find our P. Great. So now, I'm going to rewrite this as P. Well, there's like, oh yeah, let's just do it like this. Multiply both sides by 10.
Okay.
That's really just 10 over 1.
So we have 10Q. And now we don't have it as a fraction anymore.
Yeah, so now I have P
Plus.
times 10 plus M equals 10Q.
Mm-hmm.
Great. Now you get P by itself.
Okay.
Yep. So how would you
divide by
if I went like this? How would I get X by itself?
I would divide by 3.
You would divide by 3. So let's do a thought bubble. You divide by 3, right?
Mm-hmm.
You got X, and you found X equals, I'll just write it like this, as 15 over 3.
Okay.
Okay. Well, how about if I did this? How would I get x by itself?
I'd still divide, right?
Mm-hmm. Divide by what?
3.
It's exactly the same thing, right? 2 times 3 is the same as 3 times 2.
Mhm.
All right. Actually, I'm going to just keep that there. All right. Just make it a thought bubble. So now, in the spirit of Valentine's Day, what if I said P times heart
Mhm.
equals 15, and I want to get P by itself?
Okay.
How do I do that?
We're gonna still divide by heart.
I'm going to divide by heart. And what if I said that heart... What if I said that heart was really equal to 10 plus m?
I would divide by 10 plus m.
Yeah, you can just divide by your heart, which is really 10 plus m, and you can just divide by your heart, which is really 10 plus m. So over here, what's the move?
Divide by 10 plus m.
Yeah, because this is a container.
Mhm.
This is like the letter x. It's just like you have a px, and you want to get p by itself.
Yeah.
All right, so divide by 10 plus m, pow, divide by 10 plus m.
And I can't cancel the 10s, right?
You cannot.
Because it's 10q. And
And-
it's just 10.
No, you cannot cancel the 10s because there's a plus here.
Yeah, it's not. Yeah.
If,
okay.
if it was 10q over 10m, you could. But because you're adding, you cannot. You have to be multiplying everything on top.
Okay.
All right, so let's see if we answer the question. What is the before tax price? That's our P in terms of Q and M.
So P equals 10q over 10 plus m.
Yeah. So that's like a worst case scenario.
Yeah, that's
Terrible problem,
horrible.
right? But if you have this knowledge, you can do it. You with me?
I am with you.
All right, one more thing. Percent decrease. So percent decrease, that is if a pair of jeans
Mhm. Is on sale. Is the
exactly. If a pair of jeans cost $90, but they are on sale for 20% off, what is the new price in the land of no taxes? What is in Oregon? What is the new price?
Do they know?
I don't have sales tax, I think. Okay, so what is the new price? All right, so is this a percent increase problem or percent decrease problem?
So would it be 1 minus?
That's exactly right. So you'd go 90. Well, what's the setup? What's the formula?
Okay.
Every time you do these problems for SAT, I strongly encourage you to write the formula down each and every time. Not like on top of the paper and refer to it for the entire, like all the problems. Like each time, brand new, write it down.
Okay, so it's A for amount
Mm-hmm.
equals P,
Mm-hmm.
which is the OG,
Mm-hmm.
parentheses,
Uh-huh.
1
Uh-huh.
for 100 minus
Uh-huh.
R, which is the rate, which is the tax.
Awesome. Okay, so now what do we plug in where?
Okay, so the R is 0.2.
The R is 0.2. So 0.2 for R.
Okay, P is the OG, and we do not have the OG, so it's still P.
We don't have the OG?
Wait.
If you're going on, if you're physically going to Nordstrom's,
Yep.
do we know the price of the pants? And do we see, like if we're like right here and here's the rack
Mm-hmm.
and it's got like a sign on it?
Yeah.
with a percent discount on it.
Yep.
And then all the pants are just like hanging like that. Do we know this number up here?
Yeah.
How? What's our percent off?
0.2.
All right, but what would it say on the sign?
20.
It's a 20. And if you go over and you see these jeans, and it's a perfect pair of jeans, and it's got a price on it. What's that? Do you know that price?
No. Yes.
What?
92.
90.
90.
It's going to say 90. So we know the before discount number.
Okay.
So do we know the OG or the...
We know the new. That's new. That's not the OG.
What is the new price? If we know the price that's on the pants themselves. Like,
Oh!
if you're looking at clothes, like
Yep.
you're going to be like, oh, $90.
Yeah.
All right, 20% off of that number.
Yeah.
So that's the OG number.
Okay.
That's the original number. Then you're going to take that 20 and you're going to get a new number. Got it?
Got it.
Okay. So do we know the OG?
90.
90. Is OG A or P?
P.
So 90, 1 minus 0.2,
Mhm.
A equals.
Got it.
Okay. So let's go over here and figure out what that is.
Well, could we do 0.8?
Mm-hmm. So can you tell me what this problem essentially is saying in terms of our very first lesson? In terms of basically kind of like this idea.
Yeah.
30 is what percent? You remember we went and then you end up with right? So when you do that of problem, you shrink it down, right? Of is A equals P times R.
Yeah.
There's no 1 in there, right? Look over here. There's no 1 in there now either. So I can make a new problem out of this. Can you?
But must we?
Yes.
Just, I mean, that looks pretty chill to me.
No, like it's not a new problem like in terms of watch. You have $0.
Mhm.
You have $90.
Mhm.
You have 20%.
That's his 90%.
Oh yeah. That's the first time I've ever made a mistake in my life. Okay, so 20% off.
Yeah.
But look, 20% off, that's the same thing as what of?
Mm.
What's the of?
The of is of.
No. 20% off. So look, 20%. This is 100%. This is 0%. This is 80%
Mm-hmm.
of 90.
Yeah.
Look, 90. If I just said, hey, what's 80% of 90? Use your like yesterday's skills. What is 80% of 90?
We would do 90 times 0.8.
You would do 90 times 0.8. What you just did, and you didn't realize that you just did it, is you just took 20% off of 90. This is 20% off of 90. 80% of 90
all right.
is 20%. So you just went, if this is the 100, you just went, which is the same thing as going,
Yeah. Yeah.
See? So 20% off is the same thing as 80% of. You just get your 100 and you get your 1 minus your 0.2 and you get that. It's the same thing. So that's our A. We punch that out and we find our A to be 90 times 0.8. 72.
And that's it.
That's it. So when they say like what's the percent change, in this case, if you were to answer a percent change question, you would say you have to imply the up or down.
Yeah.
So you would say 20% off.
Got it.
Or I guess you'd say a 20% decrease. If in this answer you would say a 10% increase.
Got it.
But if they say if the question is saying like, what's the percent decrease, then you would just say,
Minus.
no, you would just say, oh, the percent decrease is 20%.
Yeah.
Because you don't have to say minus because the question has the word decrease in it. Okay? And that's it. That's how you do all of those. Okay, so, but it all comes down to basically, except for the very first one where I just figured out your test score, right, except for this situation, it all comes down to this one formula.
A equals PR.
A equals PR, that's it. It's just if you're increasing, you now have a new formula.
A equals P times the quantity of 1 plus R.
Good. And I like the quantity, they're very mathy.
Yeah.
And if you go A, and you want to do decrease,
A equals P times the quantity of 1 minus R.
that's it. If you know these guys, boom, 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 you can every single percentage question right that could possibly throw at you.
I didn't memorize me.
That's awesome. So this is percent of problem. This is percent increase. Oh, I'm trying to make that C work. It's just not. Increase. This is percent decrease. And all together, if I want to clump them into one category, that's percent change. Got it?
Got it.
All right, we're done.
All right, cool. Thank you.
You're welcome.
I feel like